Have scientists finally discovered first ever white hole? We all know what black holes are. They've captured the imaginations of recent sci-fi for long enough. They suck everything in, and nothing, including light, can escape from a black hole. White holes, on the other hand, are things into which nothing can enter, but which perpetually spew materials out. They are supposed to be entirely fictitious, more of a mathematical quirk than anything really. But we may have just seen one. In today's video, we will talk about the recently discovered signs of a white hole, how it affects us, and what we can expect from it. So let's get started. To begin, let's define a white hole. A white hole is a theorized region of space-time and singularity and general relativity that cannot be entered from the outside, yet can escape energy matter, light, and information. In this way, it's the polar opposite of a black hole, which can only be accessed from the outside and from which no energy, matter, light, or information can leave. In the theory of perpetual black holes, white holes appear. White holes were long assumed to be a creation of general relativity, arising from the same equations as their collapsing star counterparts, black holes. Some theorists have recently wondered if these twin space-time vortices are two sides of the same coin. A white hole seems identical to a black hole to a spaceship crew observing from afar. It's substantial. It has the potential to rotate. The event horizon, the bubble boundary separating the particle from the rest of the universe, might collect a ring of dust and gas. However, if the crew kept their eyes peeled, they could see something that a black hole can't: a belch. Carlo Rovelli, a theoretical physicist at the Centre de Physique Théorique in France, said, "It's only in the moment when things come out that you can say, ah, this is a white hole." In 1915, Einstein's field equations slammed into physics like a tsunami, and theorists are still sifting through the debris. His hypotheses not only described the force of gravity, but also delivered a paradigm-shifting message about the nature of reality. Space and time flex and fold with the mass of stars and planets, providing more than a static backdrop. This realization triggered a competition to see how much abuse space could endure from the matter passing through it. Within a year, scientist and astronomer Carl Schwarzschild calculated how space-time curved around a single mass ball and produced the first perfect solution to Einstein's equations. In his response, physicists discovered the seeds of what is now known as a singularity, a spherical mass compressed down to an impossibly dense point, wrapped so tightly in space that it pinches off from the rest of the cosmos. It creates a no man's land where the cause and effect chain is broken by the event horizon. The most famous singularities, black holes, are regions of space that are so distorted that no escapes exist. The outside universe can have an impact on the inside of a black hole's horizon, while the interior cannot have an impact on the outside. Martin David Kruskal, mathematician, extended Schwarzschild's black hole description to span all domains of space and time in 1960, and his new picture contained a reflection of the black hole singularity, though he didn't recognize it at the time. As black holes became more common, a suitable term for their theoretical twins developed. It took 40 years to understand black holes, and people have just recently focused on white holes, Rovelli explained. A white hole is a black hole's time reversal, or a movie of a black hole played backwards, much like how a bouncing ball is a falling ball's time reversal. While the event horizon of a black hole is a sphere of no return, the event horizon of a white hole is a border of no admittance, space's most times exclusive club. There will never be a spacecraft that can reach the region's edge. Objects inside a white hole can leave and interact with the outside world, but because nothing can get in, the interior is cut off from the rest of the universe. No outside events will ever affect the inside. It's more troubling to have a singularity in the past that can affect everything in the outside world. James Bardeen, a black hole pioneer and professor emeritus at the University of Washington, explained. White holes have been proposed by some researchers as a solution to the black hole information paradox, which states that information absorbed by a black hole is permanently lost during Hawking radiation, but that this would violate a quantum physics law stating that no information can ever be destroyed. If a black hole and a white hole were connected, all matter and energy eaten by the black hole would emerge out of the white hole in a different section of the universe, or a different universe entirely. This would solve the problem of data conservation. For many years, Hawking backed this theory. Similarly, a team led by theoretical physicist Carlo Rovelli proposed in 2014 that once black holes could no longer evaporate and shrink due to space-time restrictions, they would undergo a quantum bounce of outward pressure and convert into white holes. As a result, black holes turn into white holes nearly instantly after they appear. However, because of gravity's temporal dilation, outside viewers can see a black hole for billions of years. If this theory is right, black holes that formed in the early days of the universe may be on the verge of dying and bursting into cosmic rays, or another form of radiation at any time. To get to the point on how the white hole could have been created, NASA's Swift satellite photographed an extraordinarily intense gamma ray burst named GRB 060614 in a very peculiar part of the sky on a pleasant summer day in 2006. GRB 060614 did not fall into either of the two categories, short burst or long burst, and was not related with a supernova. It lasted an incredible 102 seconds, but had nothing to do with a star explosion. For comparison, most gamma ray bursts last only 2 to 30 seconds. GRB 060614 occurred in a galaxy with extremely few stars capable of exploding or producing lengthy bursts. Astronomers and astrophysicists believe the gamma ray burst appeared out of nowhere and imploded in on itself after only a few moments. Scientists proposed the theory that GRB 060614 could have been a white hole a few years later. After all, this is exactly what we would expect to observe from a white hole, a tremendous, unstable fountain of matter and energy that emerges from a point too small to perceive immediately after emerging. While it is impossible to conclude that GRB 060614 was a wonderful event, present scientific theories offer no explanation for what occurred. Despite devoting a large amount of time to observation and data, NASA scientists believe something altogether new triggered the gamma ray burst. Hundreds of telescopes have investigated the event since its detection in 2006, including Hubble. For the time being, no one can say for sure whether or not we've seen these incredible objects in our cosmos. However, general relativity fails near the singularity of a black hole. General relativity cannot adequately describe what happens within a black hole due to its energy density and curvature. We won't be able to rule out phenomena like white holes and wormholes until we have a better knowledge of physics, which currently exists solely in science fiction. However, it is worth noting that black holes were formerly deemed science fiction. So let us know what you think down in the comments section, and please give us a thumbs up by hitting the like button. Finally, don't forget to subscribe to our channel and turn on post notifications so you don't miss any updates from us. See you in the next video.